Today's lesson was taken from the Numicon Big Ideas intervention programme. It's a sort of year 5 content, so it's perfect for gap closing with year 6 children. Previously, the children will have done multiplying, dividing by 10, 100, 1000 in year 5 from calculating 7. Our diagnostic assessments have shown that around 60% of our pupils have a gap in this area or weren't able to apply it. Previously to the lesson, we have recapped place value, we've recapped decimal place value and really deepened the children's understanding of decimal place value rounding. And we looked only today at whole numbers, so really choosing those numbers to make sure the children didn't experience decimals. But our next lessons will obviously bring decimals into it. So we've got some extra resources out today. The children have got Deans in their math pack, so we're able to use the Deans in there. I did give them additional resources today of a couple of Numicon shapes, just so they could get used to moving those shapes across the place value grid. So the lesson we're going to be doing today is multiplying and dividing by 10, 100 and 1000. Now, we came across this last week or the week before. We did some problem solving involving measures, where we had to convert some measures. It's something that we struggled with a little bit, some of us did. So what we're going to be looking at in the next few lessons is multiplying and dividing by 10, 100 and 1000, including decimals, and linking that to converting measures. So it will help us with our problem solving in other areas of maths. So we did look at this example here, 64 plus 36, 640 plus 360. We noticed that this was just 10 times bigger, and that's what's going to help us today, okay? Now, let's have a look at our first bit. So, you've got a place value chart in front of you and you've got a Numicon 1 shape. Can you pick up that Numicon 1 shape for me, please? Place it in the ones column of your place value grid. Okay, and then think about what happens to that, or focus on the maths please, what happens to the value of that 1 as you move it across your place value chart. So thinking about here, what is the value of the 1? What is the value of this 1? 1 what? 1. Fantastic, or 1, okay. So let's move it across. Move it across in your place value chart. How has the value changed? What is the value of that 1 Numicon shape now? Is it 10 tens? 110, fantastic, it is 110. Brilliant. So normally we wouldn't necessarily use Numicon in this way. So when we've learned about place value in other year groups, we've normally just put a 10 shape in there, okay? We're imagining this is representing the digit 1 instead of the value of 1, okay? So now move it across again. What is the value of it there?
100, which is
100, beautiful, fantastic language. Focus on the maths for me, please, Maggie. And then moving it one more place up into my thousands column. What is the value now of that piece of Numicon, Abigail? Is it 10,000? How many thousands have you got? 1,000. So that one piece of Numicon is now worth 1,000. Fantastic. Now, let's have a little look. Here we go. Then, so those are those values written numerically. What's the relationship between the numbers then? Talk to the person next to you. What is the relationship between those numbers? Right. 3, 2, 1. So what can you tell me about the relationship with those numbers? Now what me and Abigail noticed was actually as that 1 moves, it becomes a 10. And we've added something here. What have we added, Abigail? A 0. What is that 0 doing? What's its job? It is a placeholder. Okay, so we've added that placeholder in there. So what is the relationship between 1 and 10? Now we're thinking multiplicatively, think about that multiplication symbol whistle. What is the relationship between 1 and 10? What have I done to 1? So yeah, we can say I've moved the 1 across there. What is the math that's been happening?
10.
Multiplied it by 10. So 1 multiplied by 10 is 10. 1 times 10 is 10. Is that correct? 1 times 10 is 10?
Yeah.
Yeah, we know that one. Those are our 2 easiest times tables, okay? So what's then happened as I've moved it across again? How have I got from 10, 110 to 100? What have I done to get from 110 to 100, Molly?
You times it by 10.
Times it by 10 again. 10 times 10 is 100?
Yeah.
Fantastic. So I've multiplied by 10 again. Is it the same for the next one? Have I multiplied it by 10? Connor?
Yeah.
Yeah. 100 times 10 is 1,000. Fantastic, brilliant. And what's happening to the numbers as I move along the column? Is it increasing or decreasing in value? Is it increasing or decreasing, Jamie? Increasing, fantastic. We're a bit more comfortable with the words increase and decrease than we are with ascend and descend, aren't we? Okay, fantastic. So here we go, there it is in D's. Now you can see with the D's the sort of amount that each number increases by. So if you get your 1, your 10 and your 100 out for me please. Let's have a quick look at those. Put them in the right place on your place value grid for me. Put them in the right place on your place value grid for me. So have a little look for me. So you should all have a little 1 in there, a little purple 1. So as I move across, what's really lovely about using these is you can see just how many of those 1s go into that 10. Just how many of those 10s go into it. So rather than moving just one object, we can actually see the value increasing. So by the end, your column, your 1,000 column would have this. How many of those hundreds, Justin, go into here? 10, fantastic, because 10 multiplied by 100 multiplied by 10 is 1,000. And this is 1,000 of those tiny cubes. Fantastic, brilliant. Now, thinking about this, if I were to remove this step, let's go up to this one. If I were to remove, let's put it in here. So, let's put our, move that into the hundreds. If I was to remove the middle step, what have I done for my 1 to get to 100? What have I done for my 1 to get to 100? Lena, what have I multiplied that 1 by to get to 100? By 100. And what about if I want to know what have I done from my 1 to my 1,000, Justin? What have I multiplied my 1 by to get to that thousands column? Multiplied by, what's 1 multiplied by to get to 1,000? 1 multiplied by 1,000. What if I go from a 10 to 1,000? What have I multiplied by that time? What have I multiplied by that time? Talk to the person next to you. What have I multiplied by that time? So to get from 10 to 1,000, what have I multiplied by? So multiplied by 10, multiplied by 10. Okay. Now when we look back at our slides over here, sometimes you might see it written like this. You might see it coming across like that, multiplied by 10. I'm using my left hand now, as you know I'm not very good with that, I'm a right-hander. I multiplied by 10. And again, that last jump, I multiplied by 10. And I can use this to help me from get to here, because I can see 10 times 10. 10 times 10 is 100. So I know to get from my 10s to my thousands, I multiply by 10. Brilliant. Okay. Using a 5 then, using your 5 shape in your place value chart, show me how the values at 5 change. You can write the numbers down on your whiteboard if you like, or on your other place value chart. Show me what happens to the value of that 5 as it moves along the place value chart.
15.
So what happens to that 5 as it moves along that place value chart? Well, how does the value change? Abigail, it moves from being, I haven't made this one movable. It goes from being worth, the value of it goes from being 5 to 5 tens, which is 50, 5 100, 5 100, 5,000. Okay, fantastic. Now there's a really subtle language difference there between when we say 500s and 500 as the number. Okay, really subtle difference, but it's really important. 500s is the same as 500. Can you say that for me? 500 is the same as 500. And it's really tricky not to say that. We're not looking at our hundreds just yet, we're just looking at hundreds. 500s is the same as 500. 5,000s is the same as 5,000. Okay, so when we say the number, we don't have that sound at the end. When we say the value of the digit in which column, we use that, okay? Alan? Yes, of course I can. Okie dokie. Let's go back here. So there again you can see the value. Okay, so what happens when I move from 50 to 500? What have I multiplied it by? From 50 to 500 I've multiplied it by what, Maggie? Not what I'm talking. What do I do from get from 50 to 500? What have I multiplied it by? Letitia, what have I multiplied it by? 10. Every time I move one place along the place value column, I multiply it by 10. Okay. So only when I make an extra jump, what have I multiplied by to get from 1 to 100? I've multiplied by 100. To get from 10 to thousands, what have I multiplied by? Freddie?
100.
And to get from 1 to 1,000, I've multiplied by 1,000. So what happens when a number is multiplied by 10? Tell me what you see. Tell me what you see. Talk to a person or to come up with some rules. What happens when you multiply a number by 10? Come up with some rules. What happens then? What do we notice? Well, there's many different rules as we can come up with as a class about what happens to a number when it is multiplied by 10. What happens? Alan?
When you times it by 10, you just add a 0.
When you times it by 10, you just add a 0. Who else said that? We're going to keep that one there. And I'm going to show you something that disproves it. Okay? Right, what other things have we come up with? Isabel? You had that. Okay, any other things that happen we can say as a general rule, when we multiply a number by 10, what happens? What happens? Daniel?
When you multiply a number by 10, it gets 10 times bigger.
Beautiful language. When you multiply a number by 10, it gets 10 times bigger. Okay, what else do we notice? What else do we notice? Here's 5, I multiplied it by 10. What happens? What happens? Arnie? Yeah, we're going to challenge it together then, because I want us to challenge that one. Or we can find some other things that we notice happens when we multiply 5 by 10. Have a little look. What have we done? Abigail's told us already once. What do we need to do? Or what have you noticed happens? Bradley?
It goes up one place on the place value column.
It moves one place on the place. Which direction, Bradley?
It goes to the left.
To the left. It moves one place. So I say it moves one place to the left on the place value column. Yeah? It moves one place to the left on the place value column. Fantastic. Anything else we notice, Max?
Whenever you multiply it, it gets bigger and you add a 0 on the end.
Okay, we've got our adding a 0, it gets bigger, so yeah, the number increases, that's a general rule, isn't it? The size of the number increases, or the value. Right, who's up for a challenge of challenging this for me? Oh, have you got another idea, Connor?
Yeah.
What's your other idea?
Mummy times it by 10, it's always an even number.
Oh, it's always an even number. How do you know, Connor?
It's because 10 is in 2 times 10 and that's even, so 20 and 30.
It pops it up into the 10 times table, therefore it's always going to be an even number, it's always going to be a multiple of 10. What else is it always going to be a multiple of after that?
2
And
1
and
5.
there we go, bingo. So it's always going to be an even number and a multiple of 1, 2, 5 and 10. Fantastic reasoning, Connor, absolutely brilliant. Right, challenge this top one for me then somebody. Just add a 0. When I multiply a number by 10, I just add a 0. I'm going to go Arnie challenge first. What's your challenge for that, Arnie?
Well, if you have like 76.5 and you times it by 10, you just add a 0 in the end because the decimal would go into the 1's column and there won't be a 0.
Fantastic. When we're working with whole numbers, it's easy to think, just add a 0, okay? But actually, when we start working with decimals, if I just add a 0, has the value of that number changed, Rithel? Has the value of that number changed if I just add a 0?
No.
It hasn't, has it? It's still 76.5 with just a 0 on the end. So I need to be really careful about this language. Okay. When it comes to decimals, that no longer applies. It might work with whole numbers. Actually, when you're saying just at a 0, how about if I've got the number 76 and I add a 0? Add a 0? No. Okay, so think really mathematically and precisely about the language you're using. And we can think, but when we work with decimals, that won't help us. Freddie?
But it won't always like end in an odd number, because if you have like 0.5, then you times it by 10, you get 5, which is an even number.
Oh, Connor, Freddie's just challenged you. Actually, this doesn't work if we're multiplying decimals as well. Ah, interesting. So actually, we've got some rules here that don't apply all the time. Brilliant. That would be a great reading opportunity, wouldn't it? Fantastic. So let's have a quick flick over here. What's coming next? Right, what's different? What's different? What's different this time? Taylor?
They're decreasing.
They're decreasing, getting smaller. By how many? By how many are they decreasing by? Jamie?
By 10 times.
They're decreasing by 10 times. If I decrease by 10 times, what's the language I can use? It's getting 10 times smaller. It's getting 10 times smaller. So what am I doing each time, Jamie? There's a process. What am I doing to that number? What have I done to 1,000 to get to 100?
It's like, how many thousands you're in each value that you haven't got any of them?
Okay, so last time I was multiplying by 10. What do you think I'm doing this time if I'm decreasing?
Taking away 10.
Not taking away 10. Think about it. What's the opposite of the inverse of multiplication?
Decrease.
I've got multiplication and I've got division. Okay, so I'm going to be dividing by 10 each time. So I know that 1,000 divided by 10 is 100, 100 divided by 10 is 10, and 10 divided by 10 is 1. Make sense?
Yeah.
Perfect. Bradley?
You go down to the right of place value on this time.
The rules change slightly, don't they? We're actually moving our digit one place to the right. Fantastic, I did write it down. Okay, and there's our deans, okay. Can you show me with your deans what 1,000 divided by 10 is? What is 1,000 divided by 10? Show me with your deans. Hold it up for me. Fantastic. 1,000 divided by 10 is 100. What is 1,000 divided by 100? 1,000 divided by 100. Well done. Remembering that inverse operation. 1,000 divided by 100. It works in exactly the same way. I'm dividing by 10. Dividing by 10, but actually if I take that jump, I'm dividing by 100. Show me 1,000 divided by 1,000. 1,000 divided by 1,000. Beautiful. Fantastic. What about 100 divided by 10? 100 divided by 10. Show me 100 divided by 10. So moving along that place value chart however many times you need to. Fantastic, well done. So again, we can explore that with a number, a numerical value, 4,440 and 4. So what happens when we divide a number by 10? Can we just change the rules here? Can we say that when you divide a number by 10, it gets 10 times smaller?
Yes.
Can we say that it moves one place to the right of the place value columns? And the value of the number decreases. So it's the opposite. It's the inverse of what we have done when we've multiplied, Jamie, a number by 10, 100 and 1,000. So what have I done to that 5? What have I done to that 5? To get from 5 to 500, what have I multiplied it by, Freddie?
100.
And how many place value columns does it move? 2. Okay, when I multiply it by 100, I move it 2 place value columns. What have I done to the number? What have I done to the number, Tyler?
You have divided it by 100.
100. I've moved it 2 places along. I can either work either way. I can say, well, actually, I've moved it 2 places along. I've divided by 100. Or I can look at the value of the numbers. Fantastic. So when we multiply a number by 10, 100 or 1,000, that number becomes 10, 100 or 1,000 times bigger. And it moves however many places to the left. So for 10, it moves how many places?
10.
How many place value places does it move if I multiply a number by 10?
10.
one piece on your ones column. Get that piece of Numicon, that one Numicon piece. Put it on your ones column. Multiply it by 10. Multiply. How many places has it moved? One. It's moved one place. Multiply. Put it back in the ones column for me, and multiply it by 100 this time. How many places has it moved? 2. What about if I multiply it by 1,000? It's going to be moved how many times, Talia? 3. Okay. So depending on what we multiply it by depends on how many place value columns it will move. What about dividing then? If I divide by 10, how many places does it move? So put it in your hundreds column for me. Let's start with that hundreds column. Divide that number by 10. Divide 100 by 10. Divide 100 by 10. How many places has it moved?
10.
Has it?
2.
Start with 100 for me. Move it. Divide it by 10. What's 100 divided by 10? 10. So how many places has it moved?
10.
Look at your one shape. It's moved one place, okay? It's moved one place, so divided by 100 will move 2 places, and divided by 1,000 will be 3 places. We're looking at the inverse. Everything at the moment helps us with the inverse. So depending on what you divide it by will depend on how many places you move it. Now we're going to play a bit of a game to consolidate. Oh no, we've got to do this first. What if the number is a 2-digit number? Now this is an area, 2 and 3-digit numbers, where we will tend to make mistakes. So 43, what's going to happen to my 4 tens? What's going to happen to those 4 tens, Talia?
Is it going to go to the hundreds?
Okay, so exactly the same. If I had a 1 in my tens column, 1 10 times 10 is 100. 4 tens multiplied by 10 is 400. It moves how many places? How many places to the left? And multiplying by 10. And the ones are all going to move up together. So what is 43 multiplied by 10? Have a look for me. 43 multiplied by 10 becomes 403 tens, 413 0 ones, okay? If I've got 431 by 10 multiplied, on your place value chart, your ones you can write on, show me what you're going to do. Your little yellow ones, show me what you're going to do to multiply that number by 10. How am I going to multiply 431 by 10? So I might start on my place value chart. With my 400s, 3 tens, and 1 1. Each of those parts needs to multiply by 10. So multiply my hundreds by 10, they become thousands. Multiply by tens by tens, they become hundreds. Multiply my 1 by tens, they become tens. What do I need to put in that? I'm not just adding a 0, I'm adding a mathematical language. A placeholder. I add my placeholder and I can see how it becomes. Right, we're going to play a game now. Okay. So, I'm going to show you some number cards on the board. You are going to decide, using your dice, whether it's to multiply them by 10, 100 or 1000. So if we get a 1 or a 2, we are going to multiply by 10. If you get a 3 or a 4, you are going to multiply by 100. If you get a 5 or a 6, multiply that number by 1000. Now, you can do this on your place value chart for me, please. We don't have to record this in our book. Have a look on your place value chart. You are going to be working in partners, where you have a partner. You are going to share a dice. You have your own dice. So, let's have a play. Now, my top tip for this is to write the original number down first. Then you can see how it moves. I'm going to show you a number. Your dice is going to tell you what to do with that number. So you're going to get a new number up on the board. The dice is going to tell you what to do to that number. Okay? So we're going to start with 2-digit numbers. Right, so I've got some round digit cards. Your first 2-digit number, 12. So roll your dice and decide whether you multiply it or by 10, 100 or 1,000. So what happened when I multiplied that number by 10? What happened when I multiplied that number by 10? Taylor?
It moved one space.
So each digit moved one space. So the 4 moved up to the 1,000, the 7 moved up to the tens, the 1 moved up to the 7 moved up to the hundreds, and I added in my placeholder. Okay? And what we noticed, we should have noticed those 3 digits always stay in that sequence, they never ever change. Fantastic. Right, back to the learning then. So dice down, placeholder quiz down, please. We're going to think about them dividing these 2 or 3 digit numbers by 10. Okay. Now I have to start with larger numbers because we're not looking at decimals today. We have to start with larger numbers. So looking at numbers that are divisible by 10, 100 and 1,000. Okay. But do not go into decimals, so they remain integers. So looking at these 2 examples, 540 divided by 10, on your place value grid, can you show me what's going to happen when I divide that number by 10? Start with 540 and have a think about what's going to happen to that number when I divide it by 10. Can you show me, please? What's going to happen when I divide that number by 10? Can you show me, please? On your place value grids, show me what's going to happen when I divide that number by 10 for me. Alan, get your place value grid for me, please. Write the number 540 on it. Show me what's going to happen when you divide that number by 10. Fantastic. Now, we've already said, when we divide a number by 10, it moves, doesn't it? It moves how many places to where? It moves one place, the number gets bigger or smaller? Smaller, and it moves one place to the right. So these 4 tens, 4 tens divided by 10 becomes 4 ones. 500 divided by 10 become 5 tens. Okay, so that number becomes 54. Next number then, 3,460. Have a go at that one for me, please. 3,460. Have a go at that one for me, please. Write the number 3,460 on there for me. And tell me what's going to happen. What is it? Oh yeah, don't mind that now. Let's get focused on this bit for me. 3,400. Write the number out correctly. 3,460. 3,400. Write the number down. 3,460. Fantastic. Then what's going to happen? Divide that number by 10. Divide that number by 10. Excellent. What symbol are you going to use to compare those 2 calculations? 3,600 divided by 10, is it greater, less than, or equal to 3,600 divided by 100? Who can tell me just by looking? Who can tell me just by looking and give me their reasoning?
600 divided by 10. Because it's divided by 10.
Fantastic. When we divide by 10, we're going to get a larger result than if we divide it into 1,000 equal parts, aren't we? We know that one. But fantastic if you use your place value to work it out. Brilliant. Next one then for me, please. 2,700 divided by 100 or 270 divided by 10. Greater, less than, or equal to. What did you think, Tyra? Equal to? Everyone agree? Yeah. Yeah? So using those place value grids if you need to support you. If it's on the board, I'll go, you can see it on the board as well. You don't need to get back to the pages. Okay. Don't be afraid to get your place value grid to use it to support you. You're done. Now some inverse ones. Done. done. I see none of you are getting tripped up on the one that has an additional 0 in that sequence. Well done. Okay, so write the division ones out, write 460 out. Independent money, well done. Okay, we're going to stop that lesson there for me then, guys. I'd like to give yourselves a big round of applause. So the lesson today I was really pleased with. I feel like the children really got to grips with it. It may have been a little bit easy for some of them, but actually I think it's a really important skill to practice and consolidate, ready to move on to our next piece of learning. We came up with some really amazing generalisations about what happens when you multiply and divide a whole number by 10, 100 and 1000. We attacked the dreaded just add a 0. I didn't really want to talk about decimals today, but that would have been a point we would have had to have introduced them. Luckily for me, one of my children was quite comfortable discussing this and pointing this out to some of our other children, which was really useful. And again, it's just showing how our children are getting used to that talking, again, that confidence in mathematics. They came up with some wonderful generalisations about what happens. So one of our children came up with a really lovely idea about how when you multiply a number by 10, it will always be an even number, divisible by 5, 10, you know, until another child pointed out, actually, but no, if you think back about decimals, then that changes it again. So it's really good to get the children's ideas out. And, you know, what I really hope in my classroom is that those children aren't afraid of making those mistakes and actually are able to have those conversations and challenge each other in a secure way. In terms of tomorrow's lesson, we're going to be applying this to conversions. Again, just saying with whole numbers. We had a few problems in the last few weeks where we've had to look at conversions as part of the problem, so two-step problems, and the children have struggled a bit with this skill. So it'll be really good to apply that learning to a context tomorrow. And then after tomorrow, we're going to decide as a team whether we want to then move on to multiplication using a formal written method as a recap, or whether we then want to do the same skill but look at decimals, so multiplying decimals by 10, 100 and thousands, and again applying that to conversions. That's a discussion we'll have tomorrow after we've all sort of taught the next lesson and had decided, right, okay, what are the children ready for, where do we want to take them next.